good morning, good afternoon, good evening. Whenever you are watching this video, let me welcome you all to our channel Future Endeavors. Okay, so in the previous class, we have finished discussing about the electronic configuration of the first 20 elements arranged according to their atomic numbers. Okay, and we have also understood the rules regarding the electronic configuration. If you have not watched the video, please do watch it. It will be helpful for you to understand the further topics. Okay. Next, today we are going to discuss about representation of atoms and molecules. Representation of atoms and molecules. Okay. Molecules. So, what is meant by the representation? Okay, let us first try to understand. See, by now it is at least a little bit of information has been given about elements and compounds. Okay, today just we will be briefly saying about that and how to represent the elements and compounds. We will be discussing about that. First of all, I should consider that as you have seen in the previous class that the electronic configuration of the noble gases have 8 electrons in the outermost shell except the helium. Neon and argon both have 8 electrons in the outermost shell. So as I have said that noble gases are stable, they are unreactive in nature generally, they are more stable, and the atoms of the other elements are not so stable, that is why they react. I have said this. And the very reason for the formation of molecule, do remember this thing, I am repeating it again. The very reason for the formation of molecules is the reactive nature or the unstable nature of the atoms of various elements other than noble gases. So that is why molecules are formed. Now molecules are formed by combination of atoms. We will be discussing that in details in our later class. Today we are going to consider how can we represent those atoms and molecules. Now, first of all, when we are trying to represent the atoms of different elements, say sodium, oxygen, potassium, iron, whatever it may be. When you are trying to represent the atom of an element, okay, so there are certain short forms, okay, and that shorthand representation of the name of the name of that particular element is regarded as symbol, okay. So atoms of various elements, okay, so atoms of various elements are represented by symbols, okay, symbols. And how these symbols are fixed, okay, in the first hand, when initially it was thought of, it was considered when not so many elements had been discovered. Few elements, 10, 20 number of elements had been discovered. In those times, there were really some symbols used, okay, plus, cross, arrow, like these symbols are used. Now, as the number of elements that were being discovered kept constantly increasing, it became quite impossible to formulate or to actually assign so many types of symbols to different elements. That is why after or as the different elements or with the discovery of more and more elements, what happened? It was considered that the name of the first element, okay, was taken to be the symbol for that particular atom of an element. Okay. Now this name generally they are most of the times the English names. In some cases, some Latin names are also considered to assign the symbols. Okay. For example, if you want to represent the atom of an element, say carbon, okay. So when you are trying to represent the atom of element carbon, what do? Carbon, this is the English name. So you take the first letter of this name, carbon, C. So when you write just a C in capital letter, it represents one atom of the element carbon. You consider oxygen, okay? You consider oxygen. When we are trying to represent one atom of oxygen, okay? So which letter do you take? O, capital O, okay? O in caps. Likewise, if you consider hydrogen, okay? Hydrogen, then H is the first letter, okay? H is the first letter. Then you take the capital H as the symbol of the one atom of hydrogen. Okay, so when you are writing C, O, H, all this represents one atom of that particular element. Now, there comes a confusion if we consider the element calcium. Okay, if we consider the element calcium. Now, here comes the problem. You already, if you take the first letter of the element calcium, C, you already have a symbol C which is used to denote carbon. Okay, so if we take C for calcium also, then confusion will arise. Now, to remove that confusion, what do? We consider the first two letters. Write the first letter in capitals, in caps, and then the next letter in small. Okay, so like this, you assign the symbol of the various elements. Now, if you consider iron, okay, iron. Now, in case of iron, what we consider? We consider the Latin name of the iron. Okay, so Latin name of iron is actually ferrum, F-E-R-R-U-M. Okay, so for this, what do? The symbol is the first two letters Fe. Why Fe? Now you might be questioning, sir, why Fe and not only F? Because you have already the element fluorine. Fluorine. This element has already been previously assigned the letter F for its symbol. Okay. So for iron, the F symbol is not alone used; it is used along with the E. So Fe is the symbol of iron. Like this, each element has a symbolic representation which is called the symbol of that particular element. And a symbol, remember, a symbol represents what does it represent? Symbol represents an atom, okay, not atoms, an atom of that particular element. So atom of our element, of the various elements, is denoted by the symbol that has been chosen. So this is how we can represent the atoms. Okay. Now, how the molecules are represented. Now see. So when molecules are formed, what happens? Actually, atoms combine, isn't it? Atoms combine. Now, in case of hydrogen, what happens? In case of hydrogen, two hydrogen atoms combine to form a hydrogen molecule. So when you are representing the molecule of hydrogen, it is said to be the formula. Formula represents the molecule of that particular element and it's called the molecular formula. So when you will represent the molecule of hydrogen, now remember this. So a molecule of hydrogen will be represented by the formula what? H2. Why H2? Because two atoms of hydrogen combine to form one molecule of hydrogen. So molecular formula of hydrogen will be H2. Now, why two atoms of hydrogen are combining to form one hydrogen molecule? We will be discussing this in a later class. A part will be discussed about the bonding and we will be seeing there. Okay. Now, if you consider the molecule of say water. Okay. Now, when water is formed, as I have said in the previous class, that molecule of compound will have different atoms. Molecule of an element will have the same atom. Okay, so hydrogen H2, two atoms of hydrogen combine to form the molecule of hydrogen. But in case of the molecule of water, the formula is H2. Why? Because two atoms of hydrogen and one atom of oxygen combine to form one molecule of water. Now remember this. This represents one molecule of water. Okay, so one molecule of water has how many atoms? It has 3 atoms. Okay, 2 atoms of hydrogen and 1 atom of oxygen. Likewise, you can also say you have learned carbon dioxide. So molecular formula of carbon dioxide will be, so molecule of carbon dioxide will be represented by of carbon dioxide. So this is a compound. So you expect atoms of different elements to combine, and as you know, carbon and oxygen, these two atoms combine, CO2. This is the molecular formula of carbon dioxide. Is it clear? Fine. So this is how the various molecules are represented. And here you see that again, so if we consider the molecules of the compounds, they are having atoms of different kinds, whereas molecule of an element consists of atoms of the same kind. So this is how the atoms and molecules are represented. Okay, so it is clear? Fine. So today we will end our class here. In the next class we will continue from here. If you have any question, mention in the comment box. We will be happy to solve your problem. Thank you.